everyone. Today we're here to continue our notes on our Unit 10, Day 3, applications of our 3D geometry. All right, so here's a really good application. A contractor needs to purchase 500 bricks. Now, the dimensions of each brick, 5.1 centimeters by 10.2 centimeters times 20.3. The density of each brick is 1,920 kilograms per meters cubed. So the maximum capacity of the contractor's trailer is 900 kilograms. Can the trailer hold the weight of the 500 bricks? So what we need to find is the mass of the bricks, right? Because our capacity, right, is only 900 kilograms. All right, so first let's talk about finding the volume. All right, so the volume, length times width times height. All right, now I do want to be very careful before I start plugging these numbers in, because I'm noticing that I have kilograms, but this right here is meters cubed, but these are all in centimeters. So I need to make sure that I convert all of these to meters first. So if I convert the centimeters to meters, this is 0.051 meters, 0.102 meters, 0.203 meters. Okay, so now I'm going to plug my numbers in. So all right, I'm going to put that into my calculator. And I get 0.001056006 meters cubed. All right, let me just double check that one. 0.051 times 1.0 times 0.102 times 0.203. Okay, now what I'm going to do is I'm going to actually store this as my letter V. All right, that's going to save me a little bit of time later. All right, so now let's talk about the density. All right, so my density, remember, is my mass over my volume. All right, we know the density of the bricks, 1,920. And we're looking for the mass of the bricks. We have 500 of them times this volume, 0.001056,006. All right. So what we're going to do is we're going to cross multiply. Okay, so I want to multiply this by 500 by the 1920 to get my mass. Okay. So, later, I'm going to multiply this by 500. I'm going to multiply that by my 1,920. And there we go. So my mass, 1,013. All right, so does the truck have the capacity? The answer is no. The trailer cannot hold the 500 bricks. They weigh 1,013. Oh, I'm sorry, I wrote kilometers there. Kilograms. 0.7576576 kilograms, which is greater than the 900 kilogram capacity. All right, number 6. trees are cut down and stripped of their branches for timber are approximately cylindrical. Okay, so approximately cylindrical. The timber company specializes in a certain type of tree that has a typical diameter of 50 centimeters and a typical height of about 10 meters. All right, the density of the wood is 380 kilograms per cubic meter, and it's sold at a mass at a rate of 4.75 per kilogram. Determine and state the minimum number of whole trees that must be sold to raise at least $50,000. All right, so first we want to convert all of this into the same unit. So if this right here is in meters, let's make them both into meters. So if I have my radius is actually 25 centimeters, that means my radius is 0.25 meters. All right, so finding the volume of each piece of wood here. So pi r squared h. So pi, my radius being 0.25, my height being 10. So that's going to give me 0.62 squared 5 pi meters cubed. All right, so now remember that our density equals mass over volume, and we're looking for mass. So if we cross multiply that, that's our volume times our density. So mass equals my density times my volume. So my mass, okay, I've got 380 kilograms per meters cubed. And we're going to multiply that by the 0.625 pi meters cubed. Now that's going to give us 746.1282552. Now again, these are going to cancel, leaving us with kilograms. All right, now we have a rate for our kilograms here. So we are going to then take this and we are going to multiply it by 4.75 per kilogram. All right, so what that's going to give us then is $3,544.109212 per tree. All right, so if I want to take that and I want to divide $50,000 by each tree, right, this number right here, I'm going to get about 14.107. So that's going to give me approximately, right? So if I only had 14 trees, it wouldn't be enough. I'm going to need 15 trees. Make sure you think twice the next time you see one of those giant log trucks. All right, stay tuned for the next part.